I am Rob Hirschfeld. I'm the CEO and co-founder of RackN, and I'm going to be sort of getting us started with some basic mission, vision, talking about what RackN does, so you have some grounding. If you tuned in to our previous Cloud Field Day, you'll remember that we did everything from the perspective of a fictional bank customer that we call bankend.cloud. Those demos really dove into distributed enterprise scale infrastructure, GitOps, day two operations. We really showed you the breadth of capability for RackN. Today, we're actually going to turn the telescope around, and we're going to work from the bottoms up and show you how the systems work, actually going into the architecture, the philosophy, how things are built, because that actually matters just as much as the feature set that we have. And all of the work that we're doing here is actually available. You can go to bankend.cloud, see last videos. You can actually go to git.bankend.cloud and see the code that we're going to use and things like that. And I strongly recommend you go back and look at those videos because they really show how to scale these systems to global perspective. What I want to do is also start you with some introduction about RackN. We are a software company. That means our customers install and operate our software. We're not a SaaS from that perspective. We're not a managed services company. We're not doing consulting. We actually write product. And if you've been tracking what we do, in the last 6 months, definitely from Cloud Field Day, but in the last years, we have really been working with customers to address their full lifecycle requirement. For that means going from provisioning and configuration to actually infrastructure, pipelines, and orchestration. And a lot of the capabilities that are in the product today are related to orchestration, where our customers are asking for, how do I respond to events, trigger things, how do I do webhooks and integrations? Those are really important in the day two operations story where, frankly, everybody who runs infrastructure lives. We've done some integrated labs work. We're going to show that in our third demo. Some of you have had an invitation to do a trial. The labs actually walk you through inside the product how to do infrastructure as code principles. It's a really exciting way that we've done documentation, making it really come alive. And I stress that because it's so important for people to be able to learn how to do infrastructure as code, not just RackN product. Our VMware, our customers do a lot of VMware automation from the bare metal up, and that keeps advancing. We keep doing more and more. We've made it easier to air gap install. So while everybody's very concerned about cloud, our customers want to maintain control. And sometimes that means running it completely without any interference. We don't actually manage or touch our customers. And we've gotten to bigger and bigger scales in deployments. Our biggest customers have crossed the 25,000 machines managed modes. So that's global deployments, multiple sites, just tremendous size. We have a lot of customers down in the tens, hundreds, and 252. So it sort of runs the gamut. They're all doing mixed ops. So one of the things about our customers is they do not have the luxury to pick one cloud or one hardware vendor or one location, one operating system. The essence of what we do makes it possible for them to have consistent processes across a distributed ops environment. And we're going to show you how we do things that allow our customers to work at a higher level of abstraction. They're all also multi-team. And I'll talk about this a lot with infrastructure as code, but if you don't have a way to collaborate across teams, then you don't have a really good story. And when I say multi-team, I want to be very specific. We have vertical teams where we have different development teams or different platform teams doing work along a vertical stack. But we also have teams that help those, security teams, compliance reporting teams, operating systems, cloud teams, hardware teams. All of what we're doing is actually building pipelines. And the purpose of the pipelines is to connect teams together, either by reusing code or reusing work. And I said this before, but it's really important to our customers. We are self-managed software. So everything we're doing is designed to be run by our customers. And some of you, might be thinking, this is really big enterprise stuff. Everything we do starts with one team. Starts with one use case, being really successful at what they're doing, solving a small problem first. Because that's how this works. Our customers always grow because they see us as a way to solve bigger problems, but they always start with one thing. The other thing that's worth noting here is that we've been leading market for a long, long time. We've been doing highly integrated ops for years. The market is now starting to catch up with us. People are starting to realize that the limits of Terraform as a provisioner or Chef or Cobbler or any of these Ansible tools are really starting to keep them from working as an enterprise or as a collaboration. We see this because they're forming platform teams. We see the discussion about day two orchestration as being really important, and very important to us, the prevalence of pipelines and being able to create a CI/CD pipeline. We actually do infrastructure pipelines. So we do the CD part for our customers. As a matter of fact, if you've watched movies, you've likely used some pipelines that are orchestrated by RackN in the background. So actually, pretty much every day in your life, you're using banks, service providers, media companies, healthcare companies, all customers of RackN.
A lot of gaming companies.
And definitely gaming companies. And what this boils back to is fundamentally our customers are saying we want our operations to be more like dev. That doesn't mean they want them to, sort of act like devs. What we're saying is we want the repeatability. We want modular code. We want reuse, right? Developers don't rewrite code from scratch. They have modules. They have standards. They're able to share information back and forth, or they're able actually to share skills team to team to team and company to company to company. What we see our customers wanting is an operations experience in which they expect that their operators and their ops teams can actually share work, can reuse work, can move to jobs and take advantage of those skills. And the way that works is that we see infrastructure as code as a way to look at operations as process over silos. And that can be work silos, but it's also tool silos. Things like Terraform weren't designed to integrate with the tools up and down the chain from them. And so we really work to address that. They're great tools. We're not trying to displace them. We're actually helping integrate them. We have the same challenge with people. We have people that have a lot of trouble working together because they haven't been able to synchronize their work or share their work. We help them collaborate. And we have great vendors, whether it's the hardware OEMs really doing a lot of innovation down at the hardware layer, or the cloud providers doing amazing infrastructure work. The challenge is that they're all different. And our customers really struggle with the idea that the differences between Amazon, Google, Microsoft, Linode, DigitalOcean are so significant that they end up building completely separate stacks. So we help them be consistent and abstracted. And the thing I like to reinforce here is that since we take a software development approach to automation, our automation packages are actually reused across our customer base. I want to stress this. Digital Rebar, which is our platform, is used everywhere. That's great. That's the core of the platform. It's the back end. But what we've designed allows the automation to be reused. So our customers are using the same pipelines, the same components, the same modules, and they get a tremendous amount of lift. When one of our service providers installs VMware, they're doing it the same way that the banks do it. They're doing the same way that the gaming companies do it and the healthcare companies. That ability to reuse software means that as we improve and as we fix and add new features, they actually get the benefits at the automation layer. They haven't forked off a playbook and then realized that they're never going to be able to update or patch even if somebody's improved it. We actually fix that problem by making the automation itself portable. And we're going to be going into how we do that and why that's so important.
But RackN is not a SaaS solution?
Correct. We are a software company. And that means that when we deliver automation, it's done as infrastructure as code. The modules are versioned, and you know exactly what's deployed in each endpoint that our customers install. That's a big part of the magic of how we've been able to make automation into a product instead of just the platform into the product.
What are you doing in the public sector?
Public sector has been, we have a couple of things going in public sector, but as a small startup, we have actually not done that much to push in because we need a partner for public sector work. Yeah, be delighted to. So the challenge with this and the reason why we get so excited about the reuse is we see this pattern happening all the time. And I got to listen to a little bit of your Kubernetes talk. This definitely resonated with me. Is that we are in a pattern where every ops team builds their own things, right? The dev teams build their own things. Even inside a single company, they keep creating and changing and building new things. And we see this all the time. Our customers have a tendency to want to build a integration platform, and they build one. Sometimes they even build two inside their company. They might build three. And then they realize that it's a much harder challenge to get this working, and they don't get the benefit of sharing and reusing code, or they hand it over to another team to maintain, and that becomes even more of a challenge. So what do? We are a full life cycle distributed infrastructure as code platform. I could spend probably an hour doing this, and I'm definitely not going to take much more time because we're going to get to the demos very quickly. But I do want to give you some grounding. To do a full life cycle distributed platform, we have to start with infrastructure as code. That means we have to have a consistent base of operations in every site, every customer, every place that it goes. We have to be able to provision infrastructure regardless of where it is, cloud, edge, metal, colo. We have to be able to take that and then seamlessly move into a configuration process where that machine gets set up in a correct way. No human intervention, has to be all part of a seamless flow. We have to then be able to operate that on day 2, patch, discover, conform, check, change credentials. We have to be able to have a day 2 relationship with all of the infrastructure we build. And then we have to actually look at this not as individual nodes. None of our customers ask us to manage nodes. They ask us to manage clusters and data centers and racks. So we have to be able to coordinate all of those individual pieces into systems and then operate on the systems as a group. We're going to show you all of those pieces in the demo, so I don't want to spend too much time going through it. But I do want to make sure that you understand that the whole life cycle is part of this journey. When we go into the demos, we're going to be working from individual stacks of this up. And I don't want anybody to forget that this is actually part of a broader life cycle journey. And at the end of this, actually, in a lot of ways, the beginning of this, we end up having these orchestration stories. A lot of our customers come in and say, I need you to do provisioning and configuration. What they really need is orchestration. They need to say, when this happens, I want you to take this action. When a user asks for something, deliver it. When an event happens, when a timer happens, every night, check drift in Terraform. Do an inventory scan of all my systems.
So if I will understand this integration provide the infrastructure lifecycle, right? From the creation of the infrastructure element, and then also some way to deliver an application or something like that, or only infrastructure layer?
No, it goes all the way up.
Okay.
So when we talk about lifecycle, right, our customers want to be delivered working infrastructure.
Yeah.
So that includes whatever applications they need on it, whatever security credentials, the whole thing has to be managed.
Okay.
Correct. And then when they're ready, destroy, reset, repave, rebuild infrastructure, add a node to a cluster, and then roll things through. Like all that is automation that you can then standardize and then deliver to multiple teams.
Okay.
But yeah, it goes all the way through the whole system.
Gotcha.
None of our customers have asked for, hey, I want a server and I want you to get it about halfway through the provisioning process and then have something else take over and then move it down and have something else take over. Now they have processes with that. And what they'll ask us is, hey, I need you to get a system all the way up to this point. And then I have a team that wrote some scripts. I need you to run those scripts for them and then move forward. And then when that's done, move to the next. That's a pipeline.
Yeah.
And so what we've enabled our customers to build is actually a pipeline that takes things all the way through the process. Our goal is not to become a new Ansible or a new Terraform or a new server vendor or write a new operating system. What our customers have great ones of those. What they're missing and what we provide is they have trouble connecting those things together in a way that actually is repeatable across their organization. And that's the as code. That's the infrastructure as code piece. Right. Anybody can sort of glue this stuff together with some bash scripts and hope, usually. What we're actually making that is repeatable. And the technology we do it is really cool. And we're going to dig into the hows and whys in our demos. I know y'all are impatient to get to demos, and so am I. I do want to start with a picture that sort of shows our general architecture, because this will keep you from getting lost down when we're down at the 10 feet level. And so what we've done here is we've taken a very high level architecture for digital rebar and laid it out for you so that you can understand what parts are going to operate. Because even though we've made it small enough to install on a Raspberry Pi, there's still a lot of capabilities that have to come together to make all this stuff work.
Sorry, did you just say you can install RackN on a Raspberry Pi?
Yes.
Oh, is a Raspbian version of this? Is that what you're saying?
It's a we did the Ubuntu hack of
Ubuntu.
Pi.
Okay.
Yeah.
Checking.
Yeah. No, we did actually some really interesting work called Edge Lab. that that work actually can pixie boot Raspberry Pis and some things like that. It's pretty cool.
And is there a community edition that the community could utilize on a Raspberry Pi and see what they can do with it?
There totally is. So this is software, so people can download, install the software, get a trial license, and then play with it. And then if you're a home user, we have a community edition license where you can just keep using it for your home lab. So this architecture, to sort of help you navigate it, breaks into 4 pieces. There's a when things happen, there's a what things do, there's a how it gets done, and a where things happen from that perspective. And we have much deeper architectural pictures that if we need, we'll bring up. But fundamentally, the idea here is that the system has API and event hooks, the orchestration side, driven down from a starting point. That doesn't help us if we don't have a way to control what happens. That's the infrastructure as code pieces. That's going to be, and you'll hear us use the vocabulary, things like blueprints, workflows, stages, tasks, parameters, and templates. Those are actually how we decompose automation into something that is reusable. Those 2 things come together into either a provisioning process here where we're building something, we're actually building something, that's a pipeline, or we're doing work orders where we're doing ad hoc day 2 tasks. And so the system, and this is very unique about RackN, is able to have both day 0, day 1 provisioning operations, and then switch the infrastructure into day 2 mode where we do ad hoc work order type requests. Whether we do that or not, we're still using the same basic state system. And at the end of the day, we're building a script of tasks. Those tasks get rendered into templates, which are scripts, plans, Python code, Bash, configuration files, right? At the end of the day, we're rendering templates. All things, peel away all the magic, and that's what's happening. And then the other thing that makes Digital Rebar really unique is we've built an architecture where the work that gets done is done inside of a distributed infrastructure. So we are able to run what we call a run.
Rob, something like vRealize automation for vSphere. I mean, you're plugging directly into that to do these sorts of things, or?
We can plug into vRealize automation, but we can also talk directly to the machine and put an agent on the machine and do work for that. So the way we've done this work is in these runners, and the runners, and so the runners do the work for Digital Rebar, pretty straightforward, but the runners can actually be in containers managed by Digital Rebar. So if I have to talk to vRealize, I don't have there's no place to run an agent. So I can put a vRealize broker and make requests against vRealize through a runner running on Digital Rebar itself, and then talk to vRealize on my behalf. That's exactly what we do for the clouds. When I have to run Terraform, I have to run it somewhere. That's actually running in a container on the Digital Rebar infrastructure. And then that allows us to then build up machines. Once a machine is provisioned in the cloud, it actually becomes a machine, and I can then talk directly to the machine and take actions on that machine. If I want to, I can actually flip back and forth, and we can do things like build storage arrays. We do this for our customers, where they get a machine that's COTS, undifferentiated hardware. They boot, provision it, qualify it, check it, set the BIOS. They do all their normal workflows on it, and then they install the storage operating system. We can't put a runner on that. We switch over and run in the APIs for the storage box in a container, still the same machine, but now it's being run as a proxy for the control systems. Incredibly unique ability. There's actually a picture of this where we are able to take a machine in an environment and then bounce back and forth from control in the machine to control in a container, and then move the control surface. So I'm going to show these things. It's useful to show it as an architecture because ends up being a lot of moving parts for some of these operations because of the way we've done the abstractions. And I wanted to be able to start you with some idea of what's going on. Because you can see in this chart where I'm actually showing the breadth of runners that we can have moving in an environment. It's amazing capability because it lets us bring in a tool like Terraform or Ansible or VMware tools and drive those tools as themselves, talking to whatever systems they need to talk to, and then still manage a workflow around them. And I'm seeing a slightly confused look. We'll do this work as part of the demos, and that's probably going to make it easier. I'm pausing for questions before I wrap up the section and start actually showing y'all, having Shane show you some code.
Okay, so the demo's next.
Demos are next.
Okay, so let's get the quick and easy out of the way. How's this priced?
It is priced per machine.
Okay.
It's a simple
How
answer.
do I deploy it directly into, you said I can deploy it to Raspberry Pi, so I'm assuming I need either a physical or a virtual machine to install the software?
It runs on a system, correct?
And when you say price by machine, you mean every machine that you deploy or provision or like manage, right?
Correct.
Okay.
So, and we differentiate between cloud and virtual machines and physical machines. In part because what we find for virtual machines is our customers want to create and destroy them. So we don't count that. We basically count an activity level rather than count an actual machine. Physical machines are typically easier to count, so those are just counted. That makes sense. And so we don't, let me give you the exact use case. So what would happen is somebody, our customers using our software in the ways that we prefer them to do it, which is highly dynamic, provision, reprovision, tear things down. They're going to create thousands of machines. They might never have more than 100 machines at a time. So for virtual, we're going to count the 100 machine high watermark, not the transactions. We don't do that. It's like how many concurrent operations is the system supporting for you in the virtual side or in the process control side? That's what we're going to count.
So Rob?
Yeah.
Unlike a Raspberry Pi, is that considered a machine?
Raspberry Pi would be a machine.
Ooch.
Hmm?
Nothing.
Raspberry Pi is a machine, Rod.
I understand it's a machine. You know, if you have 500 million of them, you might not want to spend it at machine level.
If you have the reason to have 500 million, you might be looking at the wrong piece.
The management of those is critically important. Doesn't matter how
Absolutely.
cheap they are.
Absolutely.
There are very few
Automation would be
alternatives.
very nice, you know?
I can presume then, but if you were to get to that kind of a scale, I would presume you'd have a licensing model that will adapt to an IoT.
Scale discounting is a thing we should consider.
Yeah. Bring us the scale, we'll bring you the discount.
No, and so our largest customers, we definitely have a scale pricing model for that. We do have some customers that don't want to commit to an annual license, and one of the models that we have is actually an activity-based process where every month they get charged based on activity, and it's an option, especially if you were very, very spiky in that. And we see customers who want to do that. Most customers will. We have customers who start there and then transition once they know their base workloads.
For those things, tech is hard, pricing and packaging way harder.
It is incredibly difficult, and we work to keep it simple. We really don't like people's. I don't want to put a meter on somebody where they're afraid to click a button because it's going to cost them money. We really want to help our customers create good management stories and outcomes. So we work for that. We do not, and this is worth noting in the pricing. We don't charge additional for the multi-site pieces. Like it's a tier to enable multi-site, but if you want to put 100 sites or 1,000 sites, like an edge infrastructure, we're not going to charge you per edge site. We're going to charge you still per machine. Because what we find is a distributed control plane is a much better management model, and we want to encourage our customers not to build massive servers. Like if you were doing Ansible Tower, a lot of times people end up with this massive Ansible Tower server, and then one team controls it, and every team is sort of like, I want access. And so what we've done is in the distributed system, you can actually have teams with their own control planes, and then you can still do a roll up, you can still share code. We really solved the distributed problem, so it's customer benefit to have a lot of endpoints.